Welcome to IBM Developer. I'm your host, Luke Shantz. We have a very exciting conversation for you today with the IBM Space Tech CTO, Naeem. Hello, Naeem.
Hi, Luke. Thanks for having me on the call.
I appreciate you taking the time. I give you a very brief introduction, so maybe you could start off with just a little more comprehensive self-introduction.
Sure, thank you. So this is Naeem Altaf. I'm IBM's distinguished engineer and also a CTO for Space Tech. I run an innovation lab in IBM and we focus, of course, the space tech and the edge computing. And we also try to look into the quantum and the blockchain solution.
Interesting. I want to get to those topics definitely in our conversation, but something that's probably on everyone's mind right now is there's been some very exciting launches recently of SpaceX to the ISS. What can you tell us about that?
Sure. Yes. So May 30th, I think it was a historical day for us. Not because, we've been doing launches for a long time, but the reason was the public and private partnership, how NASA and SpaceX came together. And almost after a decade from US soil on a US rocket, the US astronauts were launched to the space station. And that was a very exciting thing because it opens up area for many different players to emerge, all these startups. And, and this is happening because of the technological advances, which has happened in the last, I would say, 10 years, and mostly because of SpaceX, where we see that they're using the reusable rockets, and that has brought the launches to very cheap. And the satellites which are being produced, you hear about these terms: nanosatellites, microsatellites, CubeSats. So these are miniature satellites which being built and can do a lot of work which the major satellites can do, which cost almost like $200 to $300 million. These sats can cost up to max $1 to $2 million. So, and then these launchers are doing a ride-share program where they can take your launch for almost free for its STEM purposes, or else it's very cheap. Another interesting thing which I just found out, that with the space shuttle, which I still believe is the most beautiful spacecraft, they were doing a launch for 1 kilogram. It used to cost almost $19,000. Today, the cost has gone from $19,000 to only $1,900 on SpaceX. And hence, these are the reasons why it has become so exciting for all of us. Yeah.
That's so interesting. So what I'm hearing is, while this one particular launch was very exciting and had a lot of there's a lot of notable factors to it, it's also really exciting because now we're ushering in a new era of innovation where, like you said, there's going to be all sorts of new players and things are going to be happening much faster than maybe they had in the past.
Definitely. If you remember, Luke, just last year in summer, we heard there was, during their testing of the Dragon capsule, they had a mishap there, right? And almost 10 months down, they were able to fly to the space station. That is remarkable. That the speed, the agility with which they came back and proved to NASA that everything is fine and it's ready to go. In a regular, in the government agencies, that would have taken at least 3 to 4 years.
That's amazing. I'm excited that we have so much to look forward to. Something else. Okay, so what else is coming in? What other launches are coming up in the near future that we should be aware of, or what's going on?
Sure. So SpaceX, the other very interesting and ambitious projects they have is called Starlink, where they are sending these satellites. They are like a pizza box size satellites, and they are sending up in the lower Earth orbit to provide the internet connectivity to the whole globe. That's what their plans are. So they are doing launches of 60 satellites, almost like they were doing like once a month, and then it went to twice a month, and now almost seems like every week. So to date, since we launched the astronauts to space station, we had 2 launches already. The third is going to happen next week. And then the fourth launch coming from SpaceX, where they will be putting US Air Force next generation GPS satellite. So, and this is all because of reusability. They are just reusing these rockets, and it almost seems like a cookie cutter solution now, where they're just pumping out these launches almost every week.
Well, and since the retirement of the space shuttle, up until this launch last week, all of these launches had been happening with the Russian Soyuz rocket, right?
That is correct, yes. And over there, especially going to the to the International Space Station, either taking the astronauts, bringing them back, or providing them with supplies. The cost was almost $20 million per astronaut per trip. But now with SpaceX, it's dramatically low, and it's happening from the US soil. So that is a huge achievement. Yeah.
And wasn't there something also I was reading about the United Launch Alliance rockets are now using a Blue Origin rocket, whereas in the past they had been using, I guess, surplus Russian rockets that were quite old.
Yes, that's correct. Yes.
There's a lot going on. So something else that I wanted to ask you about, this is a big year for Mars as well, isn't it?
Indeed, yes. So yes, so for the Mars, there were 4 projects for this year. So 3 of them are go so far. The 4th one is because of some testing. It has been delayed for 2022. That was between the European Space Agency and Russia. It was called ExoMars. But to start here, US, as you know, it was a few months ago, a high school student named that rover called Perseverance. And it will be launched sometime third. Right now, the date is July 20th, but it can slip 2 or 3 days here because of the weather patterns. But the target is July. And this will be launched on, like you mentioned, on the ULA, the United Launch Alliance 5 rocket. And the goal of this rover will be to go and to do some drilling. They need to take, I think, 30 samples in next 2 years on the surface. And then the very cool part this time is there is actually a helicopter attached to this rover, which will take these samples and bring it to a visiting spacecraft, which will bring these samples back to the Earth. So it's like an orchestration of multiple things happening from all the way from launch to deployment, landing of rover, and then bringing samples back. So multiple vehicles will be involved. So it's very exciting. And I think I don't know if you guys have done that last year. For every launch, what NASA is doing, they're asking for people from all over the world to submit their names. So to submit their names, so they can put that name on the chip, and that chip will be on the spacecraft, in this case on the rover. So when this rover goes to Mars, your name will be also there. So if you missed out this time, look for the next one. NASA is doing this all the time now with all their launches. So luckily, I did it the previous one also. This time also has to be my name, so our names will be at least there on the on the Mars. The second project is from the United Arab Emirates. So they have a very, very ambitious space program, and they will be launching orbiter, not a rover. So their satellite will be actually orbiting Mars, learning about the atmosphere and the climate. And then they also want to put humans into Mars later down the road. So that's another one. And they are also planning for, right now the date is July 14th, so it will be sometime in July. I think, and the reason probably is the timing of how Earth is compared in the orbit to Mars. That's how these launches are decided. So, with the minimum effort, less fuel, everything, basically the most optimized path to get to Mars. The third one is from China. So China is combine both what US and UA will be doing. They want to put a rover on the ground as well as orbiter in the orbit of Mars to learn about the climate and to go and explore the surface on the Mars. And that is also planned for, I think, third quarter this year. So very exciting year. It takes 6 months for these objects to get to Mars from Earth. So in the first quarter, like in February, March timeframe, you'll be hearing some amazing stories about all of these successfully landing or orbiting Mars and sending us some really cool pictures.
So I've heard a lot of talk recently too about these very short time frames that I never would have imagined that I would be seeing the idea of sending humans to Mars like within my adult lifetime. I won't be an old man when this happens. Is this too ambitious, or is this a realistic prospect?
It's both. But then again, looking at the history of SpaceX and the other projects which they are doing something which was literally unheard of or undoable. And out of all the examples, the best example for me is how they bring these rockets down to the Earth, right? If you have seen those videos, and especially the most interesting one is when they do the Falcon, which has 3 rockets. 2 of them they comes on the ground, and one of them is on the ocean on a moving surface, right, on a floating surface. So to bring back the rockets down, this was unthinkable. Think about the weight of them and the different conditions in the atmosphere, right? The wind speed and weather and everything. And it's fully autonomous, and the computers are figuring out how to enter the orbit, where to land, when to reduce the speed, when to fire up the last engine for the last, few, probably it's like a few hundred meters, and then park it, right? That is amazing. So considering what they're doing, I'm hopeful that, in this decade, sometimes we might be able to see humans on Mars. So.
It's really remarkable times we live in. It's exciting to see the pace of innovation escalating with space. Something else that we slated here that I would love to ask about is Project Artemis and the full implications of it.
Yes, that's another very, very exciting project. We've been hearing about US going back to moon and beyond from the NASA's point of view for almost 7-8 years now. And I think last year finally it was a go. And again, if you think about sending anything to orbit or beyond moon, or beyond moon, or the probes which we have sent to Jupiter and Saturn and Pluto, and the Voyagers which are gone past the solar system, right? The ecosystem behind it is so complex. So for example, if you just take a small example of a satellite, you want to build a satellite, you want to have suppliers to provide parts for that satellite. There are testing teams, there is integration testing, there is a vibration testing, then all the certification, then taking that satellite, transporting it to the facility where it gets integrated into a fairing. From there, it gets onto the launcher, and then launching up into the orbit. The ground stations, the command and control centers communicating with that. This is just one small example. Now, when you talk about Artemis going to the moon, you're sending humans and rovers and robots and all that stuff, right? So from here, from the Earth all over the moon, they're already planning about putting gateways in the middle. So a gateway is, think of it as a service station. So you're going from point A to point B, and on the midpoint, you just want to take a break, right? So they want to put these gateways there. So the complexity is huge, and how many different things will be involved. So once you get to the gateway, from gateway, you are reaching to your target, which is the moon. You have to land there. Then from the landing, you need a vehicle to move around. You need a habitat, and you need to put something there so you can survive there, right? So in the string of all these things, the first set of contracts which were given was to the launcher. That's, of course, the first step, right? So that is SpaceX, Blue Origin, and Dynetics. So these are the ones who got the first 3 contracts to launch. And out of these 3, they all have their beautiful vehicles, but to me, the SpaceX is the most beautiful one. I just did a 3D printing on this earlier this week. So this will be their moon lander. It looks very similar to the Starship, which they will be launching for Mars as well. But that is much bigger than this one. So yes, so the landers contracts were given then, and they're also known as called HLS, which is Human Landing System. Just last week, another set of contracts were given out to the rovers. So once you land there, you need a vehicle, right? So Astrobotics was the one which was given contracts, and it will be roaming around, I think, South Pole to look for water ice deposits. Because the thing is, the reason to go to moon is to look for these water and other stuff, so we can use that and build a fuel system to go to further into the Mars and other objects into a deeper space. Then there was the intuitive machines. They also got a contract for a sort of a rover robotic thing. And the third one was the Orbits Beyond. So these 3 companies just in the last 2 weeks got contracts for the rovers. So you will be hearing more now, because there is, like I mentioned, gateways and other pieces are coming in. Yeah.
So what I'm hearing is, in addition to the rockets and the rovers and this, it's really the birth of like the supply chain and enterprise resource management industry for space.
Exactly. This is a whole ecosystem is building around for this one project from going moon to Mars, right? And there are many, many players, and you will see, because of this between the private and public partnership with NASA, you will see many new players emerging. So all these players are listed, right? They all are private companies who are coming forward and saying, let's work together to get to the moon and beyond.
So, how about some updates about what you're working on specifically? I know you have some fun projects that are like very much like advocate type projects that you can talk about publicly, and then I imagine you have all sorts of things you're working on. So, what can you tell us about?
Sure. And look, just to your last point, which you asked me about this complexity of assets, just one thing to add there. So this supply chain of building these assets for space, this is going to be very, very complex, right? And one mistake you do anywhere in this process can be disastrous for the whole program, right? So I think technologies like blockchain, because which can provide you provenance and immutability for all the information being recorded, that's going to be play a huge role. Because, for example, let's take another simple example here, right? So satellite, yeah. So for example, I say I want to send a satellite. So I'm the customer, then there's a satellite manufacturer, then there's a launcher, then there is all these authoritative bodies like FCC, FAA, who wants to make sure everything is going well. Then you have these insurance companies, regulatory bodies, right? The ground stations. So this is a very complex supply chain, and this is only for satellite. So going back to the moon, right? Like the things I mentioned, all the different players. I think blockchain is going to play a huge role, and this space asset management will be key. We already do this on the ground today with our other industrial assets. Now we will be doing this for the assets going to the space. Now, going back to what you mentioned, what we are doing here. So like I mentioned earlier, we run an innovation lab. We call it a space tech hub in Austin. And we are working on a variety of projects. So to begin with, we are trying to build a cognitive framework for the autonomous CubeSats. Basically, the goal here is, in future, you will have these set of CubeSats, let's say 13 of them or 5 or 7 of these groups of these sats, which will be in the orbit. And they will be doing different tasks. Because the technology is advanced, you have high definition cameras, much cheaper, which can fit on a smaller box now, right? So you can think of them as what we think of cloud on the ground. So you have these resources in the orbit, and they are sitting there for getting the payload. So let's say I have a swarm of these 13 CubeSats sitting there, and I send a payload. I say to them, I just got an alert from the weather company saying that there is a new hurricane brewing up on the East Coast, right? And it will be hitting the East Coast or traveling towards East Coast for next 7 days. Hey, my CubeSats, you have these very fancy IR cameras or other cameras. Put your all focus on this hurricane, right? So they get a payload, and from there on, it's fully autonomous. This framework will take control, and it will say, okay, I have these 13, who is available, who can do what, distribute the workload, right? And they all will be working in harmony to focus on this hurricane for next 7 days. And then after that event, when it's done, there is a new event. Maybe there is, God forbid, there is a fires in the forest, right? Hey, satellites, go over there and start doing a deep observation on that. So the goal is to build this framework and give it to NASA. I mean, my goal is to build this open source, and we'd love to have NASA to take a look at this. We already have discussions with them. But yeah, it will be like and because the thing is, the future, you will see a lot of these CubeSats going up, and we want them to work together. The other interesting thing is what we are working with our other technology partner, nats.io. It's an open source project. It's like we can build these clustering of these CubeSats on a fly. So for example, if our CubeSat is going and we have a proper handshake with other sort of CubeSats, we can say, hey, you have these sort of capabilities which we are looking for. Can you help us to do this task? So on the fly, we can start building these cluster of CubeSats, get the work done, and then you're out. So that is one very exciting project which we started. And IBM has this program called Extreme Blue. It's an elite program for internship, and we have our students from Stanford who will be building the application on top of this framework and the orbital mechanics on top of this. And this project should end by end of summer. So that's one project. The second project is like every year we work with NASA FDL, Frontier Development Lab. And this year also, this is our, I think, fourth or fifth year working with them. And this year we are focusing on the astronaut health. And like to your earlier point, going to the Mars, this is very critical to learn the health of astronauts, because we hear quite a bit of things, as the astronauts spend time on space station, when they come back, how they feel, the loss of mass and, bone, all these things. Now, when you are talking about Mars, it's much, much further away. So that's another project we are working on. There are some other ones very interesting with NASA we are working on, but I would say in general we are working on edge computing in space. That's the main focus. So all these future satellites which are going up, right? How can we do computation right there? Because today, when you bring data down to Earth, the bandwidth is low and the speed is very, very slow. So how about if there is an Earth observing satellite and it's taking pictures, 80% of the time the pictures are taken, there's a cloud cover, right? So I can just discard those pictures. I don't want to bring all of them down. So we can have special algorithms running on the edge being a satellite, which are looking for certain patterns or areas of interest, and only bring those pictures down instead of bringing everything down. So within the edge computing, there are a variety of things we are looking into. And the other thing is, I mentioned earlier, blockchain. We are working on blockchain solutions. The other area is the space debris. Space debris, space traffic management, situational awareness in space. That is a huge topic today in the space industry. And we are collaborating with UT Austin to work on that. And we are finalizing the official paperwork. You will hear from IBM. But yeah, our work will be to understand what objects are coming towards each other, so we can avoid the collision, because that is a huge risk as more and more sats are going up in the orbit. So that's another area of interest. The fourth area which we're working on is the blockchain. And the blockchain, like I mentioned, for the assets management, for the data exchange, is going to play a huge role, especially for the space traffic management and space debris. And last but not least, this is just exploratory for now, trying to see what can we do with quantum. Quantum is still very, very early. We are in our infant stages, but it's no harm to start thinking now. What's the art of possible? And the areas over there, 2 or 3 areas. One is the spacecraft trajectory optimization. That is a very CPU intensive task if you have to adjust the trajectory. Second thing is, again, looking at the space situational awareness. And the third thing is, okay, if we have to go and take samples on the Mars orbit, can we have a better decision making from the quantum computation? So again, quantum is, we're just thinking, exchanging ideas here, but the rest is all real and happening right now.
That is also interesting. And I have a few questions and comments. I'll work backwards. So it's really interesting to hear you say you're thinking about the quantum now. I recently went to a fintech quantum event in Amsterdam right before we went into a quarantine. Mm-hmm. And one of the things they were talking about was it's really necessary to start working on it now and thinking about it now and getting your organization involved, because yes, some of these things might be a decade out, but if you wait till then to start thinking, especially in whether it's space, which is mission critical, or mission critical in fintech, these systems you're dealing with incredibly complex legacy systems, and then you can't just change those on a dime. So you need to really, from an organizational standpoint and from a technology standpoint, and even if the technology is not ready, we have simulation. We know what these algorithms are going to look like. You can start to get familiar and understand it now. So it's really interesting to hear that, like, even though it's not ready, it's really relevant to start, being on that cutting edge. The other thing, or the next one was, you mentioned the debris, and I think for our listeners to understand, there's thousands of pieces of space junk up there, right? It could be satellites that have had collisions and broken apart, and all of this needs to be tracked. And now you just said it's about to get a lot busier up there, so the problems are going to start getting a lot harder. So, and if something goes wrong, not only is one of these things maybe cost $100 million or, even more sometimes, I imagine, but if
Yes.
something does happen, it could cause a cascading effect, which could essentially ruin orbits, whether it's telecommunications, military. I mean, it could even endanger the lives of astronauts. So this is really intense, important,
Yes.
existential threat.
Plus, it can stop the innovation on the ground, right? Because small companies, small to medium companies, they can literally go bankrupt if one of their launches fails. So yeah, it's very, very critical that we start measuring this, what's happening, start watching it, and start educating ourselves instead of just flooding. Yes.
And the last comment before we can move on to some new territory is very exciting about what you're saying about this CubeSats and this autonomous reconfigurability.
Yes.
And it reminds me, one of my favorite movies of all time is an Errol Morris documentary called
Mhm.
Fast, Cheap, and Out of Control. And it references, I just looked it up, so I have the reference to the paper, but a 1989 paper, Rodney Brooks and Anita Flynn from MIT, and it
Mhm.
is about this idea of, instead of creating the one $500 million thing, create 500 $1 million things. Now you've dissipated your risk and you have this like swarm mentality where you're essentially, it's very much like hybrid cloud, right? Where you have all these separate assets and now you can call them and reconfigure them, and your abstraction across these different nodes is
Yeah.
the new device. So it's very interesting to hear this sort of this theoretical talk is now coming to fruition, and we're seeing this as real technology, and it's going to be open source, which is amazing.
And like for our friends who work a lot in the cloud, right? Today in the world of cloud native or Kubernetes, we have this concept called microservices. This is what all these microservices are. You have broken down your task into so many small pieces and let them all do their stuff. Even if one fails, you still have, like you said, other ones to take care of things. And I actually like to call these CubeSats as sidecars, which we have a concept in cloud native. So they can be helping the bigger mission. They can be like floating or traveling with a bigger payload, helping them out. And the last thing which I like to say is we want to term these things as software defined satellites. Like you said, right, on the fly, we can do configuration. That's the key thing. Now, these are software defined. So, on the fly, I should be able to make adjustments. And last is, I think we talked last time, was we are working with Stanford University for IBM's first CubeSat. So right now, it has a little bit slowed down because of COVID, but we are on track on our mission to build the CubeSat and make it a software-defined satellite.
So I want to be respectful of your time. I know we have about 10 minutes left. I have two more questions.
Please.
The first one is, we've talked a lot about what's going on in the industry. We've talked a lot about what you're working on. But just to give our listeners a little context about the history of IBM in space, could you give me just like 3 or 4 minutes of where did IBM come from in space? Because it's a really rich history, isn't it?
Yes. Oh, IBM has, yes. And I think everybody probably noticed last year when we celebrated the 50 years of Apollo. So that's where IBM's history is. Played a very critical role in the Apollo launches, all the way from, from the computer systems to fixing, Houston, we have a problem, right? To fixing problems. So yes, from the mainframes to the software systems. But I think mainly it started from the Apollo missions. So IBM has played a huge role, and even now, since last 10 years, the NASA satellites are not going. But there's a lot of work which goes behind the scenes in the research labs with our mainframes, with our supercomputers, where IBM is involved with NASA and other research agencies. So yes, we have done a lot of work, and now because of this public-private partnership, our goal was let's start looking more on the commercial aspects also, because this space literally is, I don't know if it's the right word, exploding, but it's growing very fast, right? So we as IBM, as our heritage, we want to be a part and a leader in this area.
And my last question for you is your origin story. So specifically about space, but also in technology. So if we rewind the clock back to your adolescence and childhood, what was the spark? What was the impetus that set you on the path that you're on today?
it's just as a child laying down at night and on the because back home we because it's so hot back in Pakistan, so we have it's a normal thing in our countries that we sleep on the roof. We have flat roofs, not like over here, right? So at the night you're just laying down there. There is very less light pollution. So you're looking at the sky, and now and then you see stuff passing by, or the stars or anything. At that point, you didn't know exactly what these things were, but so that is the fascination. Looking at the space and trying to understand, right? And now 20 years later, right, with all these advancements in technology, and especially what NASA has done for us, the Hubble telescope, right? The probes the Juno probe, the probes towards the Saturn and Jupiter, the things they showed us, right? And the thing which still, fascinates me is like Voyagers, which were sent in 1970s, right? They still send signals. I mean, think about this. 50 years ago, the technology they built, it's still communicating. So that's the fascinating part. And I think the future is very bright. I tell all the kids who are, who love maths, physics, right, science part, come towards the space industry. This is just going to get bigger and bigger.
And I have one bonus question I just thought of, which is I think so interesting. Is you also you're not the only engineer in your family, and you're not the only IBMer in your family, are you?
No, I have a twin brother, and he works in Watson Health. And then I have my younger brother. He's also in the IT industry. So yes, we three are working on this computer technology industry.
I really appreciate you taking the time to chat today. I guess this is the really the last question. Is there anything I didn't ask you that I should have, or any sort of closing thoughts you'd want to include?
The interesting thing is from the software point of view, how can we contribute, right? So because the thing is, we are not aerospace engineers, right? So that's not our background. But I believe we have a huge role to play if we start saying software-defined XYZ, right? So we are starting with saying software-defined satellites. There will be software-defined gateways, all these things. And I think we as computer scientists can play a huge role, regardless of whichever company we are in. As long you're programmers and you love space stuff, we have a lot to contribute.
Well, thank you so much for sharing these stories and sharing your passion for the technology and for space.
You're most welcome. It's a pleasure again talking to you. Thank you.